Welcome to our deep dive into mastering async API calls with Aiohttp. In this video, you'll learn how to efficiently make multiple API requests concurrently, optimize performance, and handle common issues using Aiohttp. Did you know that asynchronous programming can improve your application's performance by over 50%? Welcome to our session on mastering async API calls with Aiohttp. In today's fast-paced tech world, understanding async operations is crucial. In this video, you'll learn how to handle multiple API requests concurrently, optimize your system's performance, and tackle common challenges using Aiohttp. Whether you're developing a high-traffic website or a data-hungry application, mastering Aiohttp will give you the edge you need. Let's dive in. Before we can start making async API calls, we need to set up our environment. First, ensure you have Python installed on your system. Next, create a virtual environment to manage your dependencies. This is crucial for keeping your projects clean and organized. Use the command python mvend aiohttp_end to create one. Activate your environment and install Aiohttp using pip install aiohttp. Once your setup is complete, prepare your IDE for async coding by configuring your Python interpreter to use the virtual environment. Test your setup by writing a simple script that makes a GET request to a public API. This ensures everything is configured correctly. The asyncio event loop is the core of Python's asynchronous programming. It's responsible for scheduling and executing tasks, enabling concurrent execution without the need for multi-threading. When you define a function with async def, you're creating a coroutine, which is the basic building block of async programs. These coroutines are scheduled by the event loop, which runs them as tasks. The beauty of this system is its ability to perform non-blocking I/O operations, meaning your program can handle other tasks while waiting for data. This is especially useful for API requests, where response times can vary. By understanding the event loop, you'll unlock the full potential of async programming.
Let's get hands-on with making basic async API requests using Aiohttp. Start by importing Aiohttp and asyncio in your Python script. Create an async function, such as async def fetch_data URL. Within this function, use async with aiohttp.client session as session to establish a session. This is crucial for managing connections efficiently. Next, perform a GET request using async with session.getURL as response. Use await to ensure the program waits for the response before continuing. Finally, access the response data using await response.text.experiment with various public APIs to get a feel for how Aiohttp handles requests and responses.
Handling responses and managing errors is a critical aspect of making API calls. After receiving a response, always check the status code to ensure it's within the 200 range, indicating success. For error codes like 404 or 500, implement exception handling using try-except blocks. This helps your program continue running smoothly even when errors occur. Use response.raise_for_status to trigger exceptions for unsuccessful requests. Additionally, logging errors with Python's logging module can provide valuable insights for debugging. By understanding and anticipating potential issues, you'll create robust applications that gracefully handle errors.
To maximize concurrency with Aiohttp, follow these best practices. First, optimize task scheduling by using asyncio.gather to run multiple tasks concurrently. This allows you to batch operations, reducing overall execution time. Limit the number of concurrent connections using semaphores or Aiohttp's connector options to prevent overwhelming the server. Implement timeouts to handle slow or unresponsive requests, ensuring your application remains responsive. Use context managers, such as async with, to manage resources efficiently, ensuring connections are properly closed. By following these practices, you'll create scalable applications that make the most of async programming.
Debugging async calls can be challenging, but understanding common issues can help. One frequent problem is forgetting to await a coroutine, leading to unexpected behavior. Use logging to gain insights into your program's flow and identify where errors occur. Set breakpoints in your IDE to pause execution and inspect variables, helping you pinpoint issues. Handle task cancellations gracefully by catching asyncio.canceled error exceptions, ensuring your program can exit tasks cleanly. Additionally, monitor resource usage to identify potential bottlenecks or leaks. By employing these debugging techniques, you'll be better equipped to resolve async-related challenges. Async API calls have numerous real-world applications. For instance, automating data collection from multiple APIs can significantly reduce the time needed to gather information. Web scraping becomes more efficient with async programming, as you can handle multiple requests concurrently. Real-time data processing applications benefit from async calls by minimizing latency and improving responsiveness. Additionally, async programming can enhance user interfaces, providing seamless interactions by handling background tasks without freezing the UI. Consider a case study where a company successfully implemented async calls to boost their application's performance. These examples demonstrate the versatility and power of async programming in real-world scenarios. Congratulations on completing our deep dive into mastering async API calls with Aiohttp. You've learned how async programming can optimize performance and handle multiple requests efficiently. We encourage you to continue experimenting with Aiohttp and explore advanced topics like async context managers and custom connectors. Join online communities to connect with other developers and share your experiences. If you found this video helpful, please like, comment, and subscribe. Let us know what topics you'd like us to cover next. Your engagement helps us create more valuable content. Thank you for watching.